Welcome. This is the I Am One Honors final review packet. I am going over the solutions here. This is part one. This is going to be covering numbers 1 through number 5. All right. So number 1A, it says, what is the value of x if x parentheses x plus 1 is equal to 35? Here, the solution is you have to solve for x, so that means you first of all have to get rid of the parentheses. How do we do that? We do that by distributing 7 times x and 7 times 1. That is what you see here on the left hand side. Once you distribute the 7 to both terms, the x and the 1, it can be simplified. It looks like 7x plus 7 here on the left hand side. The right hand side of equals to 35 remains the same. Right? To get x alone, you subtract 7 to both sides. That's going to be the first thing that you do after you distribute. After you distribute, you subtract the 7 to both sides. You get 7x equals to 28. Divide 7 to both sides because, again, you're trying to get the x alone. Once you do that, you get x equals to 4. 7 over 7 becomes 1, but we never really write that 1, so you're going to see in terms of just x. 28 over 7, it is 4, so the answer is going to be A. Alright, let's look at the next one. 1b and 1a is really the same. You have the 7 parentheses x plus 1, but there's some other stuff here. So there's a plus 1 here, and you have you have an extra variable and a 36 here on the right hand side. But again, we do the same process. First step is always to write the equation. Next, I am going to distribute. So this is the distributive step here. I'm going to write that to make sure you understand that I'm distributing. Because again, you're trying to get rid of the parentheses first. 7 times x and 7 times 1. This is what it looks like once you simplify. 7x becomes 7x. 7 plus 1 is 8. And the right hand side remains the same of 3x plus 36. Subtract 3x to both sides. Right? You are going to subtract 3x to both sides to get one variable on one side. That is the whole reason why you do that. It should look like 4x plus 8 equals to 36. There's an 8 here, so let's subtract 8 to both sides. Subtract the 8 to both sides to get the number alone on the other side, right? That is the reason why, and that is the logic why, right? Once you have 4x equals 28, you divide 4 to both sides to get x equals to 7. So that would be your solution. Okay? Make sure you distribute, subtract to get the variable alone. Make sure the coefficient here is 1, okay? By dividing it over. Alright, let's look at number 2 here. There should be right here. Alright, so Ryan has $20 to spend at the fall festival, and there are foods and rides. If he's going to buy this is churro, and a drink that has a total cost of $7, what is the greatest amount of rides he can go on? Each ride costs $20. The greatest number would be the maximum, so you can make an equation. Alright, some people think it is an inequality. No, it is an equation because you're looking at the maximum amount. Right, $20 is a fixed amount because that is all he has, and he will spend, right? He will spend a fixed amount of $7. Okay. The slope, or the amount that change, is the rides, because you don't know how many rides that he does want to go on. Alright, so again, this is going to be a linear equation. $20 is the total. I will make that, let's make that orange. Right, that is going to be right there. He spends a fixed amount, and the fixed amount is always the y-intercept. It's the language of the linear equation, and you do not know how many rides he wants to go on, so that is going to be your slope. Alright, because he does not, the slope is the rate of change. We don't really know how much it goes by, but we know that it is $2 per ride. Okay, that's why there's a 2 here. Alright, so subtract 7 to both sides, you get 13 equals to 2x. Divide by 2 to both sides, you get 6.5. So you're wondering, is it 6 rides or 7 rides? Okay, There's no 7 here. But you cannot say 7 rides because the max ride he can go on is 6. Because you cannot round up because you have to pay for the extra ride. You can't go up to the attendance guy and say, hey, I would like to ride the roller coaster, but I'm short 50 cents. She's not going to round up automatically, okay? That's the reason why you don't round up. Alright, let's look at number 3. Alright, here they have this equation and this equation. There's 2 equations, so this becomes a system of equations. Alright, so my goal, again, when I have 2 equations, 2 unknowns, is to get to 1 equation and 1 unknown. There's multiple steps. You can graph, you can substitute, or you could eliminate. The reason why I'm going to eliminate here is because I have an 8x and a minus 8x. I can just add those two and you're going to see it disappear. 8x plus negative 8x becomes 0, right? Let me show you. If this was red, this was red. If you add those two together, it becomes this. If this was green, this is green, so this is going to be green. If this is blue, this is blue, and this is blue. Hopefully the color coding allows you to see what became of what. This is great because I have 1 equation, 1 unknown. Divide 4 to both sides and get y equals to 5. Right? Is that what I want? No, I want to find x. So what do? I substitute y equals to negative 5 into any of the 2 equations. Any of the 2 equations. Here in this case, I'm just going to use the first equation. Right? Look at the first equation. This is the first equation. Now watch the substitution. The substitution was y equals to 5. Do you see y equals to 5 here was the color purple, and I made that substitution, so that's also going to be purple. Right? So y equals to 5. Y equals to 5. That's why the y replaces 5. Is it 5? It's not negative 5. It's 5. Yep. Then simplify. Subtract 15 to get 8x alone, then divide by 8 because you're trying to get the x alone. You get x equals to negative 3. That would be the solution right there. Again, combine the 2 equations by using elimination. Get one of the variables, or solve for one of the variables. Plug that known, the one that you solve for, back into any of the 2 equations, then solve for the other variable. In this case, we solve for x. Alright, let's look at the next one. 4. Juan determines the systems of equations below has an infinite amount of solutions. Is he correct? We have this equation and this equation. Again, you could solve this by elimination, substitution, or graphing. In this case, I am going to, what did I do? I substitute. Okay? So, watch this. You see how this was the second equation? Okay? Do you see where y is? I made that substitution. So this went into y. That's what I did. That's how I got this equation. Again, I'm substituting y equals negative 2x plus 4 into the second equation. Okay? Then I distribute because I'm trying to get rid of the parentheses like always. Then I subtract the negative 4x to both sides. I saw that the left side matches with the right hand side, so we will say that there is an infinite many solutions. So 1 is correct. There is an infinite many solutions, or the correct way is the solution set contains all real numbers. Right? That would be a more accurate way. Wait. No. It would be infinite many solutions. The set of all real numbers only work for inequalities. Alright, let's do number 5 now. Alright, Rachel was asked to graph the equation y equals negative 2x minus 2 to the right. Is the graph produced correctly? I would say yes. So let's see here. Here's the equation. I saw that the slope here was negative 2 over 1. How did I get that? I looked at this. That is really negative 2 over 1. That means I went down 2, 1, 2, and across 1. The y-intercept here is negative 2. If that does not make sense, I could pull up Paint for you, and I can show you this in Paint. Alright. So here, the y-intercept is negative 2. Okay, the y-intercept here is negative 2. right? So right here, -2, right? The slope here, this says I go down, and this says I need to go to the right. Okay, so I go down -2, 1, 2, then I go to right 1. So there you go. That is why it's graphed correctly. Alright, so there you go. That is the first part for the final review, 1 through 5.